Circuit breaker operation minimum voltage test. One of the most important tests that can be performed on circuit breakers is the circuit breaker operation minimum voltage test, or minimum voltage, which is performed in minimum voltage to operate circuit breaker tap. In this test, it is possible to find a minimum voltage which can cause the circuit breaker to operate by gradually increasing the voltage applied to the two ends of open or closed bobbin. In the first step of this test, the equipment to be used in the test is selected from among new device and AMT 105, which is set at AMT 105 by default. And here we proceed without changing it. Then you need to specify that whether you are going to perform a closed test or an open test. Note that since some circuit breakers have two open and two closed bobbins, there are open 1 and open 2 as well as closed 1 and closed 2. In this video, we're going to perform the minimum voltage test once for closed mode and once for the open mode. As a next step, you need to specify that whether the device is to detect the circuit breaker operation based on the contact reception or current drop. In this video, we're using the former, which is a more accurate and reliable method. In this method, you can also specify that whether the test is to be performed in three-phase or single-phase mode. Here, three-phase is selected. Wet is selected as the contact type so that noises cannot cause any dysfunction in the process. Note that by selecting any of the options in this section, the wiring changes. For example, if single-phase or dry are selected, you can see the change in the wiring. In this test, two methods are available to apply voltage to stimulate the bobbin. Using the manual method, you specify a particular voltage and after pressing Init test, apply that to the circuit breaker. But in the pulse ramping method, you can increase the voltage gradually and find the minimum voltage which can cause the circuit breaker to operate. By selecting pulse ramping, a graphic figure is displayed whose different parameters must be specified. Let us explain this with an example. In this example, the voltage is increased from 35 to 80 volts with 0.5 volt steps, and each step takes 0.5 seconds. The value for reset voltage is 5 volts and its application time is considered to be 0.5 seconds. After specifying these factors, the wiring is done according to the guide available in the picture. In this wiring, first the two voltage sources are paralleled in order to use the maximum current of the device, and then they are connected to the control coil to apply the fed voltage. Afterwards, in accordance with the number of contacts selected, L1, L2, and L3 contacts are connected to binary inputs to record the operation of the circuit breaker. After selecting Coil Close 1 and adjusting the wiring Init test is selected and the test runs. By opening the signal view window, you can view the applied voltage as well as the injected current. After the circuit breaker operates, the minimum operation voltage along with the amount of current drawn during the operation is displayed in Results section. By selecting Add to Report, the test result is added to the Output report. To test the open bobbin of the circuit breaker, Coil Open 1 is selected and after pressing Init test, the test is returned and the results are added to the Output report. In using the coil current method, the wiring is changed and the circuit breaker operation is detected based on the current drawn from the resource. You need to specify the minimum current which is drawn from the device when the circuit breaker operates in minimum coil current field. Here 1.5 ampere is selected. For pulse ramping, the same settings used in the previous example are used. After adjusting the wiring and pressing Init Test, the test runs. In signal view, you can see that for every pulse, current is drawn from the device. And in current 36.68 mA and voltage 16.3 volts, the test result is achieved and the results are recorded in result. The results of the test are added to the report by selecting Add to Report. Post-DC resource test. It is possible to perform the post-DC resource test in Check DC Ground section. In posts whose potential difference is provided by two resources, it is possible to examine the parallelism of the two. For example, if the post uses a positive 100 volts and a negative 100 volts resource to provide 200 volts of DC potential difference, by performing this test, it is possible to examine that how much is each of these potentials deflected from the intended 100 volts. To do this test, you need to specify the nominal voltage and maximum allowed tolerance after checking Check DC Ground. Here, 100 volts and 10% are entered in the required values, and then the wiring is adjusted in accordance with the figure. After pressing Init Test and running the test, the positive potential difference and its difference with nominal voltage, and negative voltage deviation, as well as the negative potential and its difference with nominal voltage are displayed. Check corresponding. Since in some electrical installation multiple voltage resources are used to supply different equipment, it may be necessary to test the positive and negative potential to the existing cables so that no mistake occurs in terms of positive and negative potentials. For this test, the maximum voltage allowed between the two poles of the two resources are entered in voltage drop field. To be precise, suppose that the two resources of A and B are being used to supply the equipment. Normally, there should not be any potential difference between the positive A and negative B sides of the resources. If there is any potential difference between these two, it means that they both belong to the same resource and can be used to supply the equipment. Check short circuit. By doing this test, you can test the health of a bobbin. To do so, you need to specify a voltage and a reference resistance in voltage and RF fields respectively. After doing the wiring running the test, the drawn current is measured and then the applied voltage is divided by the drawn current and the self-resistance is calculated. If this resistance is smaller than the reference resistance specified in RF field, it means that the self is short-circuited. Since it may happen that some users have also performed mega tests for this equipment and they wish to have the results in a report, in this tab they can create their intended table by selecting their desired row and column and then insert. After entering the test results and selecting Add to Report, the information will be added to the output report. Other options include Delete Report, which is used to delete the information of this page from the report, as well as the Export and Import options, which are used to export the information of this page or import them if necessary. Also, if you wish to set the characteristics entered for the created row and column as the default for this section of the room, you can use Set as Default option.